Okay, so I'm going to go through how to write ionic equations. And this is just some stuff I've pulled off the internet, but it's a nice example, quite a complicated one. So if you can do this, you should be good with anything. So it says start off with a balanced molecular equation. So what we've got here is sodium phosphate, calcium chloride, making sodium chloride and calcium phosphate. So as I said, fairly complicated. The first thing it says to do is break all soluble strong electrolytes. I don't know what a strong electrolyte is, but I don't think it's particularly important. The bit that really matters is the solubility of them. So if they've got aqueous next to them, that means that they are soluble. So you can see that we've got here our sodium phosphate is aqueous, our calcium chloride is aqueous, our sodium chloride is aqueous, and our calcium phosphate is a solid. So that indicates that it's not soluble. And therefore it isn't going to break down into ions. So it says indicate the correct formula and charge of each atom, or each ion, indicate the correct number of each ion, and write aqueous after each one. So let's just minimize that now. We shouldn't need that again now. So we take this, and we'll put it there. And then what we're going to do is we're going to break it into its constituent ions. So that's these guys here. You can see that the calcium phosphate doesn't get broken down because it's insoluble. It's a solid. Everything else goes down as aqueous. I know someone asked that today and I wasn't sure, but there you go, confirmation. Any ion that's broken down is aqueous. So now you can see that that is our complete ionic equation. It really is that simple. Note things like here you've got 2Na3 and that becomes 6Na+. What you're often asked to do though is write the net ionic equation. And the point is, we actually don't care about a lot of the stuff in here because 6Na+ appears here and it appears here. And as I'm sure you probably know, we call that a spectator ion. So we can cancel the spectator ions out here. So you can see that the 6Na+ cancels with the 6Na+, the 6 chlorine minus, or chloride minus I should say, cancels with this one, and so on, until we're just left with the phosphate ions, the calcium ions, and on this side, the calcium phosphate precipitate. So we write the leftovers out again. You've got to do quite a bit of writing to really show your full work in here, but the full answer is this one at the bottom. 2PO4 3- aqueous plus 3Ca2 plus aqueous gives you calcium phosphate as a solid precipitate. So anyway, I hope that helps. I hope you understand ionic equations now. If you're still not sure, just Google some and try and solve them. You can easily type in, any subject, the topic I want, so ionic equation, worksheet, and you can find them. Okay, there are loads online. A lot of them will have mark schemes.